All right. Uh, Welcome back to my session. And today we are going to talk about gesture recognition. And this is particularly again a neural network AI based model. And this web app can determine five different gestures by any human. It is trained to understand whether a person is giving thumbs up, thumbs down, left swipe, right swipe, or stop. So let us directly dive into how it is going to work. So I'm going to take photos, and I will capture 30 photos in a sequential manner, and it will be you can imagine as a continuous video which the model, a trained model, will feed that into it, and we will click on the product gesture and see whether our gesture was really stop or not, and whether it is able to predict the same gesture. So, and then we will deep dive into the architecture of the model, how we you like constructed it, trained the model, and so on. So let me clear this particular um, images that were captured. So you will see that right now I actually did a stop gesture, and it was able to predict the stop with a confidence of 46%. I'm clearing this particular thing, and right now let's gesture something like a thumbs up. So I'm going to start taking clicking 30 pictures in this is again a study purpose video, and for demo I've kept it simple by manually clicking 30 pictures. It could have been better by taking a 30 seconds video, and after that the model would take 30 frames out of it. But for now I'm going to for easy to demo use, I'm going to take 30 pictures manually, and let's see what happens. Our main purpose is to understand how this neural network is predicting it, and I will also explain what used to happen earlier with the technology and how it has become simple by using AI. So I'm clicking the picture. I'm going to try thumbs up maybe. So this is my first picture. It has nothing but closed fist. But now I'm starting to open my um, thumb, and let's see. I'm going to take up the thumb so that the model knows that I'm actually. This is kind of a continuous series pattern where I've actually given the thumbs up gesture. So this is my thumbs up gesture, and I'm feeding in 30 frames of images because that's that should it should have enough data to predict that it is a thumbs up gesture. So let's see. Right now we are at 20. I'm giving a thumbs up gesture. Right now you may feel that I'm taking a lot of time, but this once we automate that, or just say uh, have a higher processing power, this will not take time. The current model is 14 MB of size, which is good enough, like memory wise, and it's a trained model. So right now we have captured 30 images. Let's see if the model is able to predict the 30 images gesture that we have made, which is a thumbs up, and with what confidence. And then if it is able to say that it's a thumbs up, then I will show you the architecture of that, what we have used to do that, and it is able to say it's a thumbs up with a confidence of 43%. The confidence is low, but still, and I will explain you what this 43% means. 43% is like there, it has confidence of all the five gestures, but highest is for thumbs up with the 43%, and the lighting of my background and other image capturing, like the camera quality and image quality, all these come into effect. And while training itself, it would have a different set of images or videos that were given. So based on that, it has its own prediction model. So 40, at 43%, this is the highest for this particular category, and that's why it has predicted thumbs up. And today we have lot to talk about AI. So to start with, how initial gesture prediction used to work is, like people would wear a hardware in their hands, and then the hardware, when it moves, would capture that movement, and then you would predict the gesture. Later on, the technology moved towards camera, like capturing the photo images from camera, and then each pixels were actually designed. The coder used to design that to understand it valleys and troughs, and based on that would understand where is the fingers, count the fingers, how's the finger position, and then would actually say thumbs up. But in today's world, and this is also quite old, but still it is quite powerful for me to give a demo, is the AI, the architecture of that actually understands this complex pattern. You don't need to write a very long code, give complex instructions, and define each and every step to understand whether this is a thumbs up or not, as you can see here. So I'm going to show you the architecture of this particular, um, you can say, the model, the neural network model. And the latest, I have tried like 8 different models, out of which the latest model, I have used transfer learning. MobileNet is a model that was already trained by Google, and it is based on images that were like fed into this model, and then it has developed, and then Google gave it to like as a free downloadable use model to everyone. I used MobileNet, which has, out of that I've taken the weights of image net, weights, so that it can extract all the features from a particular image. Out of that, there is the further architecture is a bit customized as per my requirement, to understand, or the sequence of images, like the time distributed way, so that the model remembers the previous images and the gesture is in the continuous form, so that it knows that it is actually, I'm showing a thumbs up. The GRU is basically the layer where it remembers the previous images, what it showed, and based on that it finally gives the output. Total number of parameters are around 33.3 lakhs, or 3.3 million. But out of that, since I've kept the trainable false for MobileNet layers, only trainable parameters are around 1 lakh parameters, or 1000k parameters were trainable. So the training time did not take a lot of like time for training it. I had around 663 folders, out of which, if I see here in my project data, each and every like folders had images of different gestures. These are 30 images of one gesture, which is right swipe. And the train folder had every folder with a particular class, that is, let's say this is a thumbs up, then it has a class 4. So this is how the model knows that this particular folder is a thumbs up gesture. So that's it, and then I have pre-processed each and every folder's images. It learns the complex pattern and finally gives me the output. I tried different architectures, by the way, and based on different architecture I was able to finally come up with or select the most optimized and most suited model, which is the transfer learning with MobileNet. And this had a training accuracy of 91% and validation accuracy of 83%, and it was doing good. And I used 30 epochs. 30 epochs is basically the data that I had, that I mentioned, like around 20,000 images were there. So this data was, this particular model learned this 30 times. That's the epoch that it means. And after that, it basically understood that whenever a new person, even a new person, comes in and gives a gesture, it will be able to predict a particular output. So there's a lot more to talk about it, but the demo itself, it has, I think, the methodology is there in this web app about how we have done it. So I hope you loved this particular session on gesture recognition, and how powerful neural networks can be, and how easy AI has made this particular task. So this particular gesture recognition can be used by smart TV, and maybe already is in use by smart TV. And when someone says that it is AI powered, that means the neural network is able to understand these gestures. It has been trained on lot of data sets, and finally the accuracy is so good and the processing power is so better that in live itself, it within a split second it is able to understand that you are actually telling thumbs up, and asking the smart TV to increase the volume or decrease the volume, swipe 10 seconds back or right swipe and stop, and there are other gestures that you can train on. That's how the model works. And it's very easy. That AI has become, all you need to do is jump into it. So I'm quite open to collaboration, and feel free to give your feedbacks on what you feel about MobileNet gesture recognition transfer learning model with a customized architecture, GRU. There is another term called LSTM. So do let me know your thoughts. Thank you so much, and see you soon.